Going back maybe 6 months ago, might have been a poly 72 cell on your bigger jobs, or it might have been 275. The junction box would be at the top of the panel, but now we've got the junction box in the middle. A lot of guys are also changing the type of work that they do at the moment. So plenty of our solar teams are going from that residential space and entering the small commercial, entering the large commercial space. So it's important when you start a new job and you're using perhaps different panels that you think about how they may lay out differently. For example, on this panel here, the cable length might be 1 metre, but it starts up here. The cables on this one might also be 1 metre on the spec sheet, but they start in the middle. This is all sort of elementary stuff, but when you start going, well, I used to use a single solar edge optimizer per panel, but now I'm going to use, let's say, a shared one between two panels, it might mean you have to bring those cables a long distance across from let's say, panel B, right the way across to an optimizer on panel A. Do you need an extension lead? Do you need to order your optimizers or microinverters with a longer cable on it? So from the Jinko perspective, we've had this range across 2018 to 19. Eagle is your basic poly, Cheetah being your mono, and Swan being a bifacial panel. So Jinko doesn't really do glass panels or dual glass panels. We mainly do framed laminates. So that can be a framed dual glass, or it can be a clear backsheet material. So that's what you see in the Swan range. What's coming down the line now is Cheetah Plus. So effectively that's just a longer panel. So the same technology, but longer. So you're getting more watts per meter, or potentially more watts per bracket that you put in. Swan Plus, the same thing, just longer bifacial panel. Tiger here is our newest innovation, which is launching towards the latter half of this quarter. Which is a kind of like a shingle panel, so the cells are lined up together, but I'll go into that in a moment. This is basic trend as you'd expect. The power in modules is just going up and up. Some of that's being achieved by better technology. Some of it is being achieved by putting the cells closer together. Some of it is being achieved by actually making the fundamental structure of the cell better. So with respect to the Tiger panel, which is the flagship panel that we have, so in the residential space, you'll see that as a 350 watt at the moment. It's going to a 390 watt towards around the April to May bracket, depending on how the shipments go with the virus. And finally, there will be panels above 400 watt in that scale once that's been refined. So that there, what has happened to enable it to be a higher output is that the bus bars have become a bus wire, and they become more flexible, so it lets the cells go very closely together. So normally you would have the cells somewhat apart, and there'd be a gap between them, and the metal interconnectors between the cells would have to have a space to accommodate their bending radius, otherwise they'll snap. With the new technology and the new materials, you can put the cells much closer together, and the interconnect from the cells can bend a lot tighter. And therefore you get like a uniform appearance, just looks all black down the side. Yeah, the other benefit of using a bus wire instead of a bus bar, so on the front of your cells, typically you would see like 4 or 5 bus bars at the moment, and they're quite flat and they cover all the surface area. With a bus wire technology, what actually happens is that it's a circular shape, so some of the light bounces down, and also light can get here under that circular shape, whereas before it would have been blocked by the shape of the ribbon. I think we're hopefully all across the benefits of the half cell. So the benefits of half cell technologies allow us to have less current going through different parts of the panel, and therefore if there is any defects or any differences in shading, that problem or that barrier or resistance has less of an impact on the output of the whole panel. But effectively the way the half cell panel performs and a full cell panel performs in shade will be much the same, but the reliability is enhanced. The chances of hotspots developing is less. So Jeff made a point before about the reliability with having so many more connections. Does that not introduce more points of failure? So the response to that is one element of reliability is consistency. So this type of assembly for half cell is almost all robotic. So the consistency is there because it is an automated, consistent process, and therefore the way each soldering joint is done or each weld is done the same way across the field. So in fact, we see very little defects in terms of the metallic joints between cells. If you look at what causes panel failure, the number one cause of deterioration and output of a panel in the near term is a diode failure. After diode failure, then you're looking at other causes like maybe the backsheet delaminating or things like that, or a hotspot. It's very rare that you actually see a problem caused by a metal interconnection. The other thing is, let's say you stress your panel by leaning on it, or let's say the panel is stressed by thermal cycling, wind, snow, whatever. These small defects that can occur within the cell, those micro cracks, when you have a lot more bus bars on the panel and they don't occupy a lot of light capturing area, then where those defects exist inside the cell structure that you can't see with your naked eye, but you can see with an EL image, those defects where there's more bus bars, they basically don't have as much of an impact on the output.
I guess you fracture the cell to make a half cell. Do you have any problems with microfractures when you do fracture?
Okay, so the question is about how the cells are cut and how does that then create any extra stresses. So the way they're done is that it gets scribed and then snapped, so it doesn't get cut with a buzzsaw or something. And the short answer is that the wafer is in much better condition after that process than it would be otherwise. So there's no additional stress that presents as a result of doing half cell production. This here just gives a general picture of the Tiger range that's coming out. At the moment, this type of panel, there's only about 300 megawatts available in the first quarter, so we won't really see that in Australia. Like, you'll see it a little bit this Tiger, but in the second half of this year, you'll see a lot more. What Tiger lets us do is lets us do N-type. N-type in turn lets the degradation be reduced, and therefore we can offer a 20-year product warranty. So up until now, from the tier 1 manufacturers, you've seen quite short warranties. You've seen a degradation in the vicinity of maybe 1% or 2% in the first year, and then maybe 0.5, 0.6, 0.7 in the following years. These products are going to have a degradation under 0.5. This is just basically demonstrating the advantages of going to a more efficient plant in a commercial context. For a lot of the guys that are doing residential, what a product like a Tiger will offer you is the ability to give your homeowner some confidence, your building owner some confidence. It'll set you apart from people that are doing products that are perhaps less efficient or older styles of technology. From a design point of view, what I'd like to get you to think about is the general trends that are coming. So think about what happens when we change a panel. For example, maybe before you've had a rule of thumb in your office where if we've got some 315 watt panels or 275 watt panels and they've got a 20 amp reverse current fuse rating, then we can do 3 of them in parallel without fuses. Maybe as the panel gets bigger, more efficient, it increases the current. It might mean that that current is now maybe 10.1, 11 amps. Now, if you have 3 strings in parallel, you still need a fuse even if the reverse current rating is 20 amps. So some of those assumptions that you might have had, you've got to change. Now, the standards are still right, but a lot of those sort of like rules of thumb, you're going to have to look at them when you go to the bigger types of panels. The other trend that you're going to see is that some manufacturers will be introducing bigger cells. So our cells are not markedly bigger at the moment, but some of the panels that you will see in the 370 watt space, they might be 1.1 meter wide, not 1. But your rails are 4.2 and you sort of budget on 4 panels fitting on each 4 meter rail. Maybe that will not be true for you anymore. So that's the first development. So essentially we're in the 160 mil era. So companies like Jinko, we are doing 163 mil wide wafers. Other companies might do 166. By the end of the year, there will be another era, which will be the 180 mil or the 210 mil era. So everyone's trying to make a 500 watt panel that makes sense. There's a lot of factors to consider as a manufacturer, like can they fit inside the container? Is it too heavy for the tracker in the big solar plants? But essentially that's the goal, is to bring out 500 watt modules. Some of them will be wider, some of them will be longer. Yes?
You work on 40 micron cells?
No. No. So that will be down the track. So one of the concerns is as the wafers get too large, would they be vulnerable to cracks as they're being picked up by the manufacturing process? Another factor is if the wafers are too thin. when you go to dope those wafers with the different layers that make the p-n junction, they might go right through the module, and equally if they're very thin, they might be vulnerable to cracking just from routine movement. So no, we're not doing 40 micron at the moment. And the other question that always gets asked is when you introduce a new technology, how does it perform from a technical aspect? So Jinko's been very fortunate in using the DuPont backsheet and performing very well on lots of the common tests, and the good news is that the Tiger technology as well as Cheetah Plus performs either equally as well or better than the previous ranges that we've had. In some of the tests that we've done with the N-type, particularly with the bifacial, which is becoming more common in the big power plants, what you're seeing is also a lower operational temperature with these modules, which is what you'd expect, right? As the panel gets more efficient, it's soaking up more of the light. Less of that light becomes heat. Naturally, it becomes cooler. There's an example of how the new warranty will play out on the N-type products. So this is for the Tiger products specifically. The energy warranty goes out to 30 years, and there'll be a 20 or 25-year product warranty. So the typical warranty in the residential space is 20 years, and for some of the commercial products projects, we're offering 25-year wrap. That does cost a little bit more to go to that 25 years, but it does have the advantage of giving your customer sort of finally what they've expected from a 25-year warranty. Now, just one final point on the warranty there. When you're talking to the customer, it's important to think about what would a warranty service look like in year 24. So is there going to be enough panels if there's a serial defect across the board for any manufacturer? And I would say the answer is no, right? So there's not one single manufacturer, doesn't matter if it's Jinko, Trina, LG, SunPower, there's not one manufacturer who's putting equivalent stock for all the panels of this year into a warehouse, right? So if we sell 400 megawatts this year, we don't simultaneously put 400 megawatts into a warehouse to cover every panel. So if there was a widespread defect in the solar industry, what's most likely going to happen is that they'll get cashed out. So you get a refund, right? So what we do as a manufacturer, and what a lot of manufacturers will do, is they'll estimate an amount of spares that they need to keep, they'll put in the warehouse. Now on occasion, if those spares are not enough, they will offer the customer either refund or new panels. Potentially the new panels might look different than the current panels. Maybe down the track, in 25 years time, we don't know, the panels might be 10 mil thick, whereas now they're 35 mil. So those kind of things are worth thinking about when you're talking to the customer about what the warranty means. So if you look at BP Solar, for example, one of the companies that's pulled out of the market, they will typically cash out the warranty. So the customer doesn't get a whole new system, they don't get one panel, they get that you would typically bypass that panel and they would pay you some money. So when you're talking to the customer about what it needs to be covered, I think it's realistic that in the 5 years that you guys are offering as a CEC approved retailer or as an installer generally, you would offer them a 5-year whole of system warranty. It's realistic that you could replace that panel in that time frame, but down the track 20 years, it's more likely they'll be offered either a replacement system or something that looks different. So imagine if all the panels developed a defect, they wouldn't get swapped the exact same ones, they'd get swapped for the current range or cash. So when you're doing it, interaction with your customer, if you explain that up front, people are pretty happy with it, because that's going to be true for everyone. So yeah, anyway, I just thought I would make those points. Think about the current rating, think about the position of the cables, how far they are. When you look at a data sheet and it says 1.2 and your current panels are 1.2, is the new panel you're going to get the same length that you've been working with before? If you're going to do a job where it's landscape, does that change how that cable layout is going to run for you? Do you need to order your optimizers or microinverters with a longer cable to match up with the panel? Ask your wholesaler also what the cable length is on the panels that they're supplying, because a lot of the data sheets are made for the global market. In the global market, the cables are very short. In Australia, they tend to be, on Jinko product anyway, the full cell will have 1.2 metre, the half cell will have 1 metre. Yeah, sorry, did you have a question? Okay, great. Right, thanks very much, guys. That's all I had for today. Hopefully that's useful. If you've got any technical questions on panels, come and find us up the back. We've got Stone here as well with myself in that table just